Let's solve these synthesis problem. Let's say that from benzene, I want to make this compound on the right-hand side. So how do I do that? First, we remember two things. When I observe these, the compound, notice that this is the activating group. So the reaction, once you install the bromine, bromobenzene reacts slower than benzene. Take that into account. And then the other group, the isopropyl, that's an alkyl group, and it is activating. So I'm going to start from benzene installing the activating group. So that will react faster for the second reaction. So in doing that, that means I'm going to be using 2-chloro propane and with aluminum trichloride. When I do that, that's my Friedel-Crafts alkylation. And I have that's my product, isopropyl benzene. So I had installed an activating group, which means that that will direct ortho pair. Question is, can I do a bromination now? If I do the bromination directly on this, say that I do bromine and say that I do iron, which in situ will generate iron tribromide, my Lewis acid. And so what will happen in this case? Well, I'm going to get a mix of products. I'm going to get the bromo in ortho and in para. So that two products and not exactly what I want. That's what I want. So what can I do to obtain only that one? So the strategy here is using a blocking group. So because I need more room, I'm going to erase that. So again, this will give me two products. I don't want that. I only want that in ortho. But this also has a problem that isopropyl being big. Well, if you do this with this pathway, this is major. Because this being large, bromine is going to go para. So not what I want. So I'm going to now use another strategy. If I have the isopropyl, so let me do another arrow. From the isopropyl benzene, I'm going to use a blocking group. What it is I'm going to use sulfuric acid, fuming sulfuric acid. So fuming, meaning you have SO3 fuming, which your electrophile is SO3. All right, SO3. What it does, this is a large group. And because it's large and isopropyl is large, I'm going to make, it's going to prefer, this is activating orthopara, yes, but this is large. Your major product is the parasulfonic acid. And this is my blocking group. And it is very good. We use that because we can install the sulfonic acid group by using fuming sulfuric acid, and we can remove it afterwards by using diluted sulfuric acid. So that's the first step. I'm going to block that position. And when I do now the bromination step, this position is occupied. So ortho-pair director, the only place that is left empty, let's say, is the ortho position. So I'm forcing bromine to go. Let's do another Lewis acid. So this is occupied, so it needs to go ortho. So now I'm going to have my bromine where I need it, but this is still a sulfonic acid. So what do I do now to get to that product? I need to remove this group, which is blocking. The way we remove it is we use diluted sulfuric acid and heat. So again, let's review the strategy. I wanted that. I wanted the bromine in the ortho position with respect to the isopropyl group. I first did the alkylation and give me that, the ortho pair directing. So if I directly do the bromination, I'm going to get two products, but the major is not what I want. The major is the para-bromo. So instead, I need to use a blocking group. In the group that we use here in electrophilic aromatic substitution is installing the sulfonic group. This reaction is reversible. With fuming sulfuric acid, you install the group, and with diluted sulfuric acid, you remove it. So in that pathway, then from isopropyl benzene, I use fuming sulfuric acid. This being a large group is going to go para respect to the isopropyl group, so the two groups are large. Now that is blocked, the next substitution doesn't have another place to go but go ortho. And also, this is deactivating, that's activating, so this is going to determine the substitution. So ortho to the isopropyl. Once I have that, what I need to do is to remove the blocking group, so diluted sulfuric acid. So this is studying how we do that is talking about synthesis strategies using electrophilic aromatic substitution.